Okay, hello everybody, what's going on? This is Mohammed. Welcome to another video. In this video, I'm going to teach you how to solve for this indefinite integral. So we have here the integral of 1 divided by x multiplied by x plus 1 multiplied by x plus 2 all the way until we get to the last term, which is x plus m. So how can we solve for this integral? Well, the first idea that should come up to our mind is basically partial fractions. So that's exactly what we're gonna do here. We're gonna use partial fractions to rewrite the expression inside the integral, and that's gonna make it easy. If we are successful in expressing this term as constant divided by x plus a constant divided by x plus 1 all the way to a constant divided by x plus n, then basically every term of those is going to be the constant multiplied by the natural logarithm of the absolute value of the denominator. So the idea here, how can we basically calculate for the constant? So that's what we're going to show here in this video. So I will let the integral I equals to, I will start with the first term, which is basically a0 divided by x, plus the second term, which is a1 divided by x plus 1, plus the third term is going to be, the third term is going to be a2 divided by x plus 2 all the way until we get to the last term, which is basically, an divided by x plus n, and I will put everything between two parentheses, dx. Now, how can we solve for the constants a0, a1, a2 all the way to a? And there's a very simple way, basically. A0, to solve for these constants, a0 can be solved directly by taking out x from the original expression and evaluate everything else at the root of x, which is basically 0. So that's what we're going to do here. Okay, so a0 is going to be equal to 1 divided by x plus 1 multiplied by x plus 2 all the way until we get to the last term, which is x plus n. Everything should be evaluated at the root of x, which is x equals 0. So if we substitute x equals 0 in every term in the denominator, that's going to give us 1 multiplied by 2 multiplied by 3 multiplied by 4 all the way to n. So that's going to give us n factorial in the denominator. So this is basically going to be equal to 1 divided by n factorial. So we're done with the first constant. Now we're going to go to the second constant. So the second constant, a1, we're going to follow the same exact procedure here. Okay, so it's going to be also 1 divided by, now x is going to disappear. What's going to disappear is the second term, which is x plus 1. So the next term is going to be x plus 2 multiplied by x plus 3 all the way until we get to the last term, which is x plus n. And we have to evaluate everything at the root of x plus 1, which is basically x equals minus 1. So if we do that, that's going to give us 1 over minus 1 multiplied by minus 1 plus 2, which is 1, multiplied by minus 1 plus 3, which is 2, 3, 4, 5, all the way to n minus 1. So basically, this is going to give us minus 1, this is going to give us yes, minus 1 because of the first term, and the rest is going to be n minus 1 factorial. So it's going to be minus 1 divided by n minus 1 factorial. Now let's go ahead and also find a2 following the same exact procedure. That's going to give us 1 divided by, now x is going to appear, x plus 1 is going to appear, x plus 2 is going to disappear, so the next term is going to be now x2, x1, x plus 1 disappeared. For a2, x plus 2 is going to disappear, so the next term is going to be x plus 3. All the way until we get to the last term, which is x plus n. Everything has to be evaluated at the root of basically x plus 2, which is minus 2. So x equals minus 2. Okay? So if we do that, if we evaluate minus 2, that's going to give us 1 over minus 2 multiplied by minus 2 plus 1, which is also minus 1. So minus 2 multiplied by minus 1, that's going to give us 2 in the denominator. So we have 2 here. Okay, and then minus 2 plus 1, minus 2 plus 3, that's going to give us 1. Minus 2 plus 4, that's going to give us 2, all the way to minus 2 plus n, which is n minus 2, so that's going to give us n minus 2 factorial, okay? So we can notice, and the numerator is going to be equal to 1, because we have minus 2 multiplied by minus 1, that's going to give us 1, actually, and 2 in the denominator. So if you pay attention, and if we can also follow this procedure to find the next few terms, then we can come up to a generic formula for AK, actually, which is going to be like this. Okay, so it's going to be basically minus 1 to the power k, because we have noticed that when k is even, it's going to be positive. When k is negative, is as odd. When k is even, it's going to be positive. When it is odd, it's going to be negative. So it's basically minus 1 to the power k. We should have something like that in the numerator. And also, we notice that in every term, we're going to have also n minus k factorial. Okay, so of course, n minus k factorial. And the other term is basically was 0 factorial in A0, was 1 factorial in A1, was 2 factorial in A2, and that's what we're going to find if we find the next few terms. So basically, this is going to be k factorial, okay? So now our integral can be rewritten like this. The integral of the summation, we can express the coefficient in a summation that starts from k equals 0 all the way to n of the same expression that we have found out. Okay, so minus 1 to the power k divided by k factorial multiplied by n minus k factorial, and this is going to be multiplied by 1 divided by x plus k, of course, dx. Okay, so the first term is constant, basically, and we're going to be left out with the second term, which is basically the natural logarithm. The integral of that is the natural logarithm of the absolute value of x plus k plus the constant c. Okay, so that's going to give us the summation from k equals 0 all the way to n of the same exact term, which is minus 1 to the power k divided by k factorial n minus k factorial, the natural logarithm of the absolute value of x plus k plus c. And that is basically the final answer to this integral. What I'm going to do here, I'm going to highlight this final result in pink so it is clear and easy to see, okay? If you like this video, guys, hit like. If you have any comments, please put your comments in. And don't forget to subscribe to the channel and click the bell so you don't miss anything in the future. Thank you for watching, and see you in another video.